Hello everyone, welcome to our channel 361 Physics, and this particular video is the second part of our target to solve 2000 plus MCQ. So let's begin with question number 1. In question number 1 it is said that tripling the speed of a motor car multiplies the distance for stopping it by. Okay, so it can be solved by using uh, conservation of energy, or you can say that work energy theorem. Okay, so I'm going to write here the work done to stop the car is equal to change in kinetic energy, which is equal to uh, suppose this to be final kinetic energy minus initial kinetic, or suppose this to be initial kinetic energy and final kinetic energy, because as the energy is scalar quantity, so subtraction just uh, do not make any kind of changes. Okay, so as we have given that the car is going to uh, in rest, so this part of kinetic energy must be 0. That means F times T equal to half mv square, sorry, F u square. And from this expression, F is constant, m is constant, half is constant. That's why we can easily confirm that T is proportional with the u square. That means distance is proportional with the square of velocity. And as the velocity is tripled, that means it is make 3 times. So we can easily say that D will be 9, because if we write here in the place of u 3, then square of 3 makes 9. That's why the distance, okay, distance will be 9. So our option C is correct option. So distance is equal to 3 square, which is equal to 9. So option C is correct. Okay, फेरि एकचोटि भनिदिउँ, ट्रिपलिङ भनेको 3 टाइम्स इन्क्रिज गर्नु हो। भेलोसिटीलाई हामीले 3 टाइम्स इन्क्रिज गर्यौँ भने कुनै पनि कारले कति डिस्टेन्समा स्टप गर्न सकिन्छ भन्ने कन्सेप्टको क्वेसन हो। हामी यहाँ वर्क इनर्जी थ्योरम अप्लाई गर्दैछौँ। वर्क डन हो यो, वर्क डन टु स्टप द कार। हाफ एमबी स्क्वायर माइनस हाफ एमयु स्क्वायर लेखे पनि हुन्छ। हाफ एमयु स्क्वायर माइनस हाफ बी स्क्वायर लेख्दाखेरि अझ बेस्ट के हुन्छ भने फाइनल काइनेटिक एनर्जी 0 हुन्छ। अलमोस्ट भनेकै छ। सो सल्भ गर्न इजी हो, अरू खासै केही चेन्जेस छैन। सो एफ इन्टु डी इक्वल टु हाफ एमयु स्क्वायर, यहाँबाट फोर्स कन्सटेन्ट एन्ड हाफ कन्सटेन्ट एम कन्सटेन्ट, बिकज यो प्यारामिटर्सहरूमा भेरिएसन भनेको छैन क्वेसनले। सो डी डाइरेक्टली प्रोपोर्सनल विथ यु स्क्वायर हुन्छ, अनि युको भ्यालु हामीलाई 3 टाइम्स बनाउनु छ, त्यसैले 3 स्क्वायर भनेको 9 हुन्छ है। सो यसरी हामीले यसलाई सल्भ गर्न सक्छौँ। Okay, now we are going to solve question number 2. Two masses m and 4m are moving with equal kinetic energy. The ratio of magnitude of their momenta is. Okay, so it is given their kinetic energy are same. So kinetic energy of first equal to kinetic energy of second, as we have expression of kinetic energy in terms of momentum as p1 square by 2m1 equal to p2 square by 2m2. Okay, so हामीसँग यो रिलेसन छ, एन्ड देन हामीले यसलाई जस्ट रेसियो निकाल्नु छ। p1 by p2 को रेसियो चाहियो। सो p1 स्क्वायर by p2 स्क्वायर, यो 2 क्यान्सल आउट गरिदिउँ है। सो m1 इज by m2 हुने भयो। m1 भ्यालु अफ m1 इज m, बट द भ्यालु अफ m2 is 4m. So on cancellation and on taking the square root, we can easily say that the ratio of momenta is 1 by 2. So our correct option is answer C. Okay, now we are going to solve question number 3. If a man increases his speed by 2 meter per second, his kinetic energy is doubled. The original speed of the man is. Okay, so as we have the relation of kinetic energy in terms of velocity is equal to half mv square. Okay, so I'm missing of expression sir kinetic energy ko kinetic energy equal to half mv square हुन्छ हामी एजुम गर्न गइरहेछु मैले केही समय यहाँ लेखेको छैन हामी यहाँ एजुम गर्न गइरहेछु फर्स्ट काइनेटिक एनर्जी एन्ड सेकेन्ड काइनेटिक एनर्जी एज E1 एन्ड E2 र यहाँ हामी इजिली हाफ एम एन्ड फर्स्ट काइनेटिक एनर्जी एक्चुअलमा हामी देयर इज नो चेन्ज भनेको छ तर सेकेन्ड काइनेटिक एनर्जी चाहिँ हाम्रो इनिशियल भेलोसिटीमा 2 एड गरेको छ सो बेटर हामी E2 बाई E1 लेख्दियौँ किनभने E2 लेख्दाखेरि हामी अझ छिटो सल्भ गर्न सक्छौँ सो हाफ एम एन्ड V प्लस 2 होल स्क्वायर बाई हाफ एम V square. These two cancel out. Okay, and what about this? The ratio is 2 because it is said that the kinetic energy is doubled. Okay, now V plus 2 whole square becomes equal to V square times 2. Okay, and on taking the square root, we can write here root 2V equal to V plus 2. And on solving these two, we can easily write root 2 minus 1 V equal to 2, which means that 2 by root 2 minus 1, and on taking doing a rationalization, we will get here the answer as 2, this is plus and this one is plus 2 root 2 plus 2. This is new value of velocity, and this particular expression is here in option number B. That's why option B is our correct option. Okay, now we are going to solve question number 4. If BPK denotes the velocity, momentum and kinetic energy of a particle, then the correct relationship is. Okay, so we have to find the correct interrelationship between these three parameters. So let us begin from first number. As we know that momentum is the product of mass into velocity, and here is given what the time rate of change of kinetic energy. Okay, so on calculation, rough calculation, we can write the time rate of change of kinetic energy as 1 by 2 m and d v square by 2. Okay, so here I have supposed m to be constant. Okay, so on writing the derivative of v square with respect to t, this one is dv square by dt. Okay, so on further solving we can not get this kind of expression, that's why this is not correct. Now let us check whether this is correct or not. So here it is given momentum equal to rate of change of velocity, which means this side represent here acceleration. That's why momentum is not equal to acceleration, so this is also incorrect. And here kinetic energy equal to half, and this is momentum. The velocity, uh, the differentiation of momentum with respect to velocity. So suppose I'm going to differentiate this with respect to velocity, then I will get here dp by dv as m. Okay, so its expression will be here half m, which is not equal to the expression for kinetic energy. That's why this is also incorrect. So finally we can conclude that option D is correct. But before doing some ongoing to any kind of conclusion, let us find whether this is correct or incorrect. So here the kinetic energy is differentiated with respect to velocity, so we can easily write here 1 by 2 m b square is differentiated by b, so it will be half m and 2 b. These two will cancel out mb. So option D is correct option. Now here we are in question number 5. A portion of mass 0.2 kg travels along a space curve with a velocity this much, 4i plus 3j meter per second. After 10 seconds, its velocity becomes this much, 6i plus 8k meter per second due to action of a conservative force. Then work done on the particle is this much, 7.5 joule. The power of the force is 75 watt. The power of force is 0.75 watt. Information is insufficient to calculate the work done and power. Okay, so from the option we can confirm that we have to check the work done and power, the value of work done and power, and then we have to find the correct option. Okay, so as we know that work done is um, the change of kinetic energy. Okay, from work energy theorem we can say that the work done is equal to change of kinetic energy. Okay, so I'm going to use that particular relation here. Okay, so W, this is work done, half, let's suppose m is given here, m is mass, and v square minus u square. Okay, on rough calculation we can find the value of v as 6 square plus 8 square root over, and its value will be 10 meter per second, and value of u equal to 4 square plus 3 square, which is equal to, sorry, root under, this is equal to 5 meter per second. Okay, so on using this all value here we will get the uh, value for work done. So 0.2 this is, and here 10 square minus 5 square, well, this will be 0.1, and 10 square is 100 minus 25, that means 75. So its value is 7.5 joule. So first option is correct. Now we have to find out the value of work, not work done, power. So as we know that power equal to rate of change of work done. So work done is 7.5 and time is given here 10 seconds. So it will be 0.75 watt. So our option C is also correct. Okay, that was question number 5. Now we are going to discuss the question number 6. The kinetic energy of an air molecule. Okay, the kinetic energy of an air molecule is 10 to the power minus 21 joule. What its value in electron volt? So this is quite easy because we just have to apply this uh, relation. 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. Joule. Okay, so we have to convert joule into electron volt. That's why we have to divide this value by 1.6 into 10 to the power minus 19. On uh, dividing these two value, we can get the expression in electron volt. Okay, so uh, just do this division and write its proper answer in our comment box. Thank you. Okay, now after solving this question number 6, we are going to solve question number 7. And in question number 7, it is given the kinetic energy of a body of mass 2 kg and momentum 2 Newton second is. So, sorry. Okay. This is our question number 7. The kinetic energy of body of mass 2 kg and momentum 2 Newton second is. So just we have to find the kinetic energy by using the value of momentum and mass. So as we know that kinetic energy can be expressed as the ratio of square of momentum to the twice of mass. So its value is 2 square and 2 into 2, which means 4 by 4, that means 1 joule. So our answer is option number A. Okay, now we are going to solve question number 8. A bullet hits and get embedded in a solid block resting on a horizontal frictionless table. What is conserved? Okay, so as in the question it is mentioned that the bullet strike or hit the target and get embedded, that means bullet remains shear, which means that this is an example of uh, inelastic, okay, collision. So in this particular collision we know that kinetic energy changes but momentum remains constant. Okay, so our proper option is option A, momentum alone remain conserved. Now we are going to solve question number 9. If the momentum of a particle is increased by 100%, its kinetic energy increased by. Okay, so from this question I'm going to suppose new momentum as p dash, and from the question we can write new momentum equal to p plus 100% of p. So p, and this will be 100 by 100. Okay, 100 by 100 times p, that means once again p. Okay, so uh, the value of new momentum will be twice of p. Okay, so new momentum becomes 2 times of initial momentum. Yeah, so p, and this will be p, which means twice of p. Okay, so this is new momentum. Now we have to find out the change in kinetic energy, percentage change in kinetic energy. Okay, so before doing that I'm going to suppose the kinetic energy in first case is E1 and its value is p square by 2m, and kinetic energy in second case is p dash square by 2m. Okay, now we have to find out the percentage change in kinetic energy is what. So to find out this we have to just do some calculation here. So I'm going to write del in the place of del E2 minus E1 by E1 into 100. Okay, it means that we can easily take 1 by 2m as common. Okay, and from here, from these two expression I'm going to write here 4p square, and here is p square, and again it has to be divided by p square by 2m. Okay, on taking these two common, p square and 2m, all of this can be cancel out here, and here remains 3 inside this bracket. So 3 times 100 makes 300. Okay, so percentage change in kinetic energy is 300. Okay, now we are going to solve question number 10. A bomb of mass 16 kg explodes into two pieces of mass 4 kg and 12 kg. The velocity of 12 kg mass is 4 meter per second. The kinetic energy of the other mass is. Okay, so as there is no external force acting in this particular condition, so we have to use here the conservation of momentum concept. So here the momentum of uh, large mass, that means 12 kg of mass, is the product of its mass and velocity, which means that we can equate the product of 12 into 4 with the product of 4 with unknown velocity. Okay, and on solving this we can easily find the value of velocity. Okay, so I'm going to write here 12 into 4, which is equal to 4 into v. V is unknown, so v will be equal to uh, 12. This is velocity. Now to find the kinetic energy we have to use half mv square, and this is a half. Mass of small part is 4 and velocity is 12 square, so this will be 2, and as we know that square of 12 is 144 into this is 2, so it will be 288. So our answer D is correct answer. Okay, now we are going to solve question number 11. A rocket of mass 1000 kg is consuming fuel at the rate of 40 kg per second. The velocity of gases ejected from the rocket in 5 into 10 to the power 4 meter per second. The thrust on the rocket is. Okay, so to solve this kind of for sorry uh, problems, yeah, we are going to use the concept of force. And from the Newton's second law, force can be written as the time rate of change of momentum, and it can be written as the time rate of change of momentum as dmv by dt. And here the time rate of change of mass is given, that's why I'm going to write the velocity as uniform, and here we can easily write dm by dt. Its value is 40 and velocity is 5 into 10 to the power 4. So 5 into 10 to the power 4 into 40. So 1 0 uh, will add from this particular uh, 0, and 4 5s will be 20. Once again one more 0 added here. So its answer will be 2 into 10 to the power 6 Newton. ओके, सो यसलाई बुझ्ने के भनेको छ भन्दाखेरि अब रकेटको मास छ हैन, अनि फ्युलको रेट अफ कन्जम्पसन यति दिएको छ, अनि भेलोसिटी रकेटको यो भ्यालु दिएको। हामीले यसमा के निकाल्नु पर्ने छ, थ्रस्ट, अपवर्ड थ्रस्ट, रकेट माथि जाँदैछ हैन, अनि यहाँ फ्युल कुन रेटमा निस्किन्छ, त्यो फ्युलको रेटको भनौँ न, फ्युलको एजेक्सन रेट जुन हुन्छ त्यही रेटको बेसिसमा फोर्स लाग्छ है। त्यसैले गर्दाखेरि हामी के अप्लाई गर्न सक्छौँ भने यहाँनिर न्युटन सेकेन्ड ल, र सेकेन्ड लले के भन्छ भने, सेकेन्ड लले भन्छ कि फोर्स इक्वल टु टाइम रेट अफ चेन्ज अफ मोमेन्टम। यहाँ हामीले मोमेन्टमलाई एम इन्टु भी को फर्ममा लेख्यौँ, र रेट अफ चेन्ज अफ मास दिएको छ, द्याट्स वाइ डिएम बाई डिटी लेख्न सकिन्छ। र भेलोसिटीलाई युनिफर्म सेन्समा हामी लिँदैछौँ, त्यसले भी टाइम्स डिएम बाई डिटी, अनि यो सब्स्टिट्युसन गऱ्यौँ। सब्स्टिट्युसन गर्दाखेरि 4 5 जा 20 हुन्छ, र यो जिरोले यहाँ एउटा जिरो थप्यो, द्याट मिन्स 10 पावर 5 हो। 4 5 जा 20 हुँदा फेरि एउटा जिरो थप्यो, 10 पावर 6 हो, अनि 2 यहाँ हुनु, 2 इन्टु 10 पावर 6। okay, so that is question number 11. Now we are going to solve question number 12. Okay, question number, this is our question number 12. When a uranium-238 nucleus initially at rest decay by emitting an alpha particle, which is the uh, nuclei of helium, with speed u meter per second, the recoil velocity of residue nucleus in the meter per second. यहाँ हामीले बुझ्नुपर्छ, जस्तो युरेनियम 238 बाट यहाँ अल्फा पार्टिकल इजेक्ट भयो हैन। इजेक्ट हुँदाखेरि यो एउटा सिस्टम हो जसमा एक्सटर्नल फोर्स लागेको छैन, त्यसैले यो यसमा हामीले कन्जर्भेसन अफ मोमेन्टम लगाउन सक्छौँ। अब यसको कन्जर्भेसन अफ मोमेन्टम लगाउँदाखेरि हामी के बुझ्छौँ भने मास अफ अल्फा पार्टिकल हामीलाई 4 दिएको छ। सो यसलाई हामी डाइरेक्ट गर्न खोज्छौँ। मास अफ अल्फा पार्टिकल इज गिभन एज 4 इन्टु velocity is u and mass of uranium is 238, and I'm going to write its velocity as v। र क्लोज सिस्टम भएकोले गर्दाखेरि यसमा एक्सटर्नल फोर्स एक्ट नभएकोले गर्दाखेरि टोटल इनिशियल मोमेन्टम एन्ड टोटल फाइनल मोमेन्टमको सम 0 हुन्छ, सरी इक्वल हुन्छ। सो इनिशियली रेस्टमा भएकोले गर्दाखेरि यसमा इनिशियल टोटल मोमेन्टम के छ, इनिशियल मोमेन्टम यसको 0 छ। इनिशियल मोमेन्टम इज 0 एन्ड दिस इज वाट फाइनल मोमेन्टम हैन। सो इक्वेट गर्दाखेरि हामीले के गर्न सक्छौँ, 238 इन्टु भी इक्वल टु माइनस u into 4 because u equal to 0 हुन्छ यहाँ। सो v equal to minus u or 4u है, यहाँ जुन प्याटर्नमा छ त्यही प्याटर्नमा एरेन्ज गर्ने हो भने माइनस 4u बाई 238 यस्तो के अप्सन आउँछ। सो हामीले हेर्ने हो भने क्वेसन को प्रोपर अप्सन हामी अप्सन नम्बर डी मा हेर्दैछौँ है। सो हाम्रो अप्सन नम्बर डी करेक्ट अप्सन देखिन्छ। यस्तो ब्रेकिङ, स्प्लिटिङ, एक्सप्लोजन त्यस्तो वर्ड भएको कुनै पनि सिस्टम भनिएको छ भने त्यहाँ हामी इजिली कन्जर्भेसन अफ मोमेन्टम अप्लाई गर्न सक्छौँ है। Okay, so next question. A gun fires a bullet of mass 50 kg with a velocity 30 meter per second. Because of this, the gun is pushed back with a velocity of 1 meter per second, the mass of the gun. So you again key question भन्दाखेरि again this question is related with the conservation of momentum. So initial momentum is 0 because bullet as well as gun is के त रेस्टमा छ, and final momentum भनेको 50 gram of bullet, that means 50 by 1000 kg मा चेन्ज भयो, 30 इसको velocity छ, and then after velocity of gun is given 1 and its mass suppose m। so यसलाई सल्भ गर्दाखेरि हामीले इजिली निकाल्न सक्छौँ m इक्वल टु minus 50 upon 1000 into 30, 0 0 cancel out, 5 2s are 2, 1.5 times, so 1.5 kg is our answer. So this is our answer. Okay, now we are going to solve question number 14. The distance between two rails in 1 meter, is 1 meter on a circular track of radius 400 meter. The outer rail must be raised by how much distance so that a train moves with a speed of 20 meter per second without any friction? Take z to be 10. अब यो क्वेशनलाई यसरी बुझ्नुपर्छ। Suppose this is the rail and its inclination is theta and this is height, यो हामीलाई निकाल्नु पर्ने छ। The distance between two rails हामीलाई दिएको छ, दुईटा रेल बिचको डिस्टेन्स हामीलाई इजिली प्रोभाइडेड छ। The distance between two rail यहाँ दिएको छ 1 meter apart, 1 meter apart। Okay, so यो हेर्ने हो भने इजिली टर्न हुनु भनेपछि हामीले बुझ्नुपर्छ यो एक्सप्रेसन एंगल अफ ब्रेकिङ को, जसमा हामीलाई थाहा छ फर्मुला tan theta equal to v square upon r g हुन्छ। and from this picture we can find out the value of tan in terms of h, and this one is base. So here I am going to write h by 1 and v is 20, which means 20 into 20, radius is 400 and g is 10. So we are going to solve this 2 and 2, that means this overall cancel out here. Okay, so this 20, okay, so I'm going to cancel it, slightly time लाग्छ किनभने यहाँनिर अलिकति यो अटो सेभिङ मोडमा जान्छ कहिलेकाहीँ, अनि अटो सेभिङ मोडमा हुँदाखेरि केही समय लाउँछ। ओके, 20 and these two cancel out, 2 2s are 4, okay, and these two will cancel out here, 0 So it will be 1 by 10, that means 0.1, and this is in meter. If you multiply this by 100, then answer will be 10 centimeter. So our correct option is option. Question number 15. A particle moves in a circle of radius 30 centimeter with a constant speed of 6 centimeter per second. The acceleration is. Okay, so सर्कलमा मुभ गर्नु भनेपछि त्यहाँ दुई खालको एक्सलेसन हुन्छ, एउटा हुन्छ सेन्टिपिटल एक्सलेसन, अर्को टेन्जेन्शियल एक्सलेसन. सेन्टिपिटल एक्सलेसनको फर्मुलेसन हुन्छ v स्क्वायर अपन r, because the expression for centripetal force is mv square r. र यसलाई हामीले कम्पेयर गर्ने हो भने ma सँग in the place of a we get v square r. okay, so centripetal acceleration निकाल्ने हो भने v square को भ्यालु हामीले दिएको छ 6 square and r is 30. 30 means 0 point, let it be 0 point लेख्दाखेरि अप्ठ्यारो हुन्छ. That's why I am going to write it 30 by 100. okay, so this will be 36 into 100 by 30. So this will cancel out here. 1, 2, that means 120 meter per second. So option D is correct option. Now I am going to solve question number 16. A car of mass m travels with a uniform speed v on a convex bridge of radius r. When the car is at the middle of the bridge, the force exerted by the car on the bridge. So nature of bridge is convex. Suppose this is the, okay, this is bridge and car is here. Now we have to find the force exerted by the car on the bridge. Okay, so here its mass act downward. Okay, and normal reaction acts upward. These two forces are here, and as we know that this type of question can be solved by using the concept of vertical circle. यस्तो क्वेशनहरुलाई भर्टिकल सर्कलको कन्सेप्टबाट पनि सल्भ गर्न सकिन्छ. त्यसैले अब यहाँनिर हामीले हेर्ने हो भने नर्मल रिएक्सन अपवर्ड छ, वेट डाउनवर्ड छ, र यहाँ अर्को कम्पोनेन्ट पनि एक्ट हुनुपर्छ. त्यो कम्पोनेन्ट भनेको हामी इजिली भन्न सक्छौं सेन्टिपिटल फोर्स. सेन्टिपिटल फोर्स जसले टुवर्ड्स द भर्चुअल सेन्टरतिर, भनौं न भर्चुअल सर्कल एजुम गर्ने हो भने भर्चुअल सर्कलको सेन्टरतिर तान्छ. ओके, सो हामी के भन्न सक्छौं भने यो वेटको कम्पोनेन्टबाट नर्मल रिएक्सनलाई सबट्र्याक्सन गर्ने हो भने यसले रिमेनिङ फोर्सले mv स्क्वायर बाइ r प्रोवाइड गर्छ हामीलाई. mv स्क्वायर बाइ r, सपोज the radius to be capital R. Okay, so R will be equal to mg minus mv square by r. भनेको मतलब यति बराबरको फोर्स जुन चाहिँ नर्मल रिएक्सन हो त्यति बराबरको फोर्स यो कारले यहाँ लगाइरहेछ, किनभने त्यति बराबरको नर्मल रिएक्सन एक्ट हुन्छ. त्यसलाई हाम्रो अप्सन सी करेक्ट अप्सन देखिन्छ. ओके, सपोज गरौँ है यसको ठाउँमा यस्तो शेपको नदिएर हामीले कन्केभ शेपको दिएको भए चाहिँ के हुन्थ्यो भन्ने क्वेशन पनि आउन सक्छ. कन्भेक्स शेपको भने कन्केभ शेप. सो इफ द ट्र्याक इज इन दिस शेप, दैट मीन्स कन्केभ शेप, एन्ड भेहिकल इज हियर, भेहिकल यहाँ छ भने हामीले बुझ्नु के पर्छ भने यसमा लाग्ने फोर्सेसको कुरा गरौँ. वेट डाउनवर्ड लाग्छ, नर्मल रिएक्सन अफ कोर्स अपवर्ड लाग्छ. क्लियर? एन्ड देन नर्मल रिएक्सनबाट वेट सबट्र्याक्सन गर्ने हो भने r माइनस mg सबट्र्याक्सन गर्ने हो भने रिजल्टिङ सेन्टिपिटल फोर्स लाग्छ. दैट मीन्स यो केसमा नर्मल रिएक्सन इक्वल टु mg प्लस mv स्क्वायर बाइ r हुन्छ है. यो भर्टिकल सर्कलको कन्सेप्टबाट पनि सल्भ गर्न सकिन्छ. म्याक्सिमम टेन्सन एट द लोअर पोइन्ट एन्ड मिनिमम टेन्सन विल बी एट द अप्पर पोइन्ट. सो यसबाट हामीले बुझ्छौं कि म्याक्सिमम टेन्सन लाग्छ लोअर पोइन्टमा, मिनिमम टेन्सन लाग्छ अप्पर पोइन्टमा. कन्भेक्स शेप छ भने मिनिमम टेन्सन, and concave shape छ भने maximum tension लाग्छ. Okay, so its answer is mg minus mv square by r. Now we are going to solve question number 17. A car is traveling along a country road that resembles a roller coaster track. If car travels with a uniform speed, the force exerted by road on the car is maximum at. So this is quite easy because we have already discussed about this kind of problem. Uh, Here in A point the nature of track is convex. In B point this is we can say inclined plane, okay, and is in C point this is concave in shape. So we have already discussed that at concave shape the maximum tension acts, okay. So we can say that at C, that means our option, correct option is C. At point C the tension is maximum. हामीले अघि नै डिस्कसन गर्यौं कन्भेक्स शेप छ भने मिनिमम टेन्सन, यो स्लाइड टाइपको शेप छ है भनेको मतलब इन्क्लाइन प्लेन जस्तो, यहाँ हामीले जनरली टेन्सन त लाग्छ तर कम्पेरिटिभ रूपमा कम लाग्छ यहाँको कम्पेरिजनमा, अनि यो कन्केभ सर्फेसमा सबैभन्दा बढी लाग्छ, त्यसलाई हामी यो पोइन्टमा पोइन्ट सी मा सबैभन्दा बढी म्याक्सिमम टेन्सन लाग्छ भन्न सक्छौं है. So you have हाम्रो solution for question number 17. Now we are going to solve question number 18. A tube of length L is completely filled with an incompressible liquid of mass m and closed at both ends. Okay, the tube is then rotated in a horizontal plane about one of its end with a uniform angular velocity omega. The force exerted by the liquid on the other end. Okay, so यसलाई हामीले पहिला त पिक्चर बनाउनु पर्यो. यसले भन्न खोजेको के हो भन्दाखेरि एउटा ट्युब छ र यो ट्युबलाई एउटा एक्सिसको अबाउटमा रोटेट गरिदैछ र यो ट्युब कम्प्लिटली फिल्ड अफ छ केले भन्दाखेरि यो ट्युब फिल गरिएको छ वाटरले. अब हामीलाई निकाल्नु पर्ने छ इट्स फोर्स एक्जर्टेड बाइ द लिक्विड अन द अदर एन्ड. अनि त्यो निकाल्नु पर्ने छ फोर्स, यो अर्को एन्डमा फोर्स कति छ भनेर निकाल्नु पर्ने छ. हामीले बुझ्नु पर्छ यहाँनेरि सानो एउटा सेक्सन लिन्छौँ हामी, किनभने हामीलाई मासको कन्सेप्ट थाहा छैन, यहाँ कति मास भनेको छैन हामीलाई. यहाँ ओभरअल मास त यति छ, हामीलाई त्यति थाहा छ ओभरअल मास, तर यहाँनिर डिस्ट्रिब्युसन कस्तो छ भन्ने कुरा हामीलाई थाहा छैन. यस्तो यहाँनिर हाम्रो भनौँ न मोमेन्ट अफ इनर्सियाको कन्सेप्ट अप्लाई गर्ने जस्तो देखिन्छ पनि, बिकज यहाँ एंगुलर भेलोसिटी भन्ने कन्सेप्ट आयो भनेपछि मोमेन्ट अफ इनर्सिया तिरबाट सोच्नु पर्छ है. त्यसैले सबभन्दा पहिला हामी मोमेन्ट अफ इनर्सिया तिरबाट सोच्न खोज्छौँ यसलाई, ठीक छ. ओके, सो त्यसैले मैले यहाँनिर यो रफ स्केच गर्दैछु. अब यो रफ स्केच गरिसकेपछि हामी यसलाई फर्दर सल्भ गर्छौं. सो हामी यसलाई समहाउ हामीले मोमेन्ट अफ इनर्सियामा गरेको क्याल्कुलेसन केही बेसिसमा गर्न चाहिँ सक्छौं है. जस्तो हामी एजम्पसन के गर्छौं भन्दाखेरि यो सानो सेक्सन छ, यो सेक्सनको सपोज थिकनेस dx छ अर लेन्थ भनौं न dx छ र यसको पोजिसन छ x. समहाउ मोमेन्ट अफ इनर्सियामा हामीले एउटा मेटल बारको मोमेन्ट अफ इनर्सिया निकाल्ने कन्सेप्टको बेसिसमा गर्न खोज्दैछौँ है. एक्ज्याक्टली त्यही त होइन तर प्रोसिजर त्यस्तै छ. ओके, सो अब यसलाई रोटेट भनेको छ, रोटेसन गर्दैछ हैन. हामी के गर्छौं भने यहाँनिर यो स्मल जुन लेन्थ छ यसमा भएको सेन्टिपिटल अर सेन्ट्रिफ्युगल फोर्स भन्छौं. सेन्ट्रिफ्युगल भन्दाखेरि यतातिर लाग्ने फोर्स, यो एन्डमा लाग्ने फोर्स. सो यति सेक्सनमा भएको मासले लगाउने फोर्स कति भनेर निकाल्छु पहिला. सो दैट विल बी स्मल फोर्स, दैट मीन्स डेल एफ इक्वल टु है हामीले mv स्क्वायर बाइ r जुन लेख्छौं त्यसलाई हामी एंगुलर फर्ममा लेख्ने भने m है. यो स्मल m भनेको मास पर युनिट लेन्थ हो, स्मल m, एन्ड देन यसलाई मैले स्मल लेन्थले मल्टिप्लाई गरे यसले दिन्छ यो सेक्सनको यो यति लेन्थको मास दिन्छ है। अनि यहाँ मैले डिस्टेन्सले मल्टिप्लाई गरे एमआर ओमेगा स्क्वायर फर्मुला हो एक्चुअलमा ओमेगा स्क्वायर भयो ठिक छ। अब ओभरअल फोर्स निकाल्नु छ भने सिम्पली के गर्ने भने यहाँबाट यहाँसम्म इन्टिग्रेसन गरिदिनु र इन्टिग्रेसन गर्दा यसको लेन्थ एल हो भने ओभरअल लेन्थ हामी निकाल्न सक्छौँ। ओभरअल लेन्थको इन्टिग्रेसनबाट हामी ओभरअल फोर्स निकाल्न सक्छौँ। जुन हामीले इन्टिग्रेसन गऱ्यौँ भने 0 टु एल इन्टिग्रेसन गऱ्यौँ भने हामीले इजिली के पाउँछौँ भन्दाखेरि एम ओमेगा स्क्वायर त युनिफर्म भयो एक्स डिएक्स हुने भयो एन्ड यसलाई सल्भ गर्दै जाने हो भने एम ओमेगा स्क्वायर हुने हो। एन्ड फर दिस यसको लागि के गर्न सकिन्छ भन्दाखेरि हेर्ने ल यहाँनिर यो एक्स स्क्वायर बाई 2 हुन्छ यहाँ इन्टिग्रेसन 0 टु एल हुने भयो होइन। अनि अन सब्स्टिट्युसन हामी अप्पर लिमिट हाल्छौँ लोवर लिमिट त त्यसै 0 भइगयो यो एम ओमेगा स्क्वायर यहाँ एल स्क्वायर बाई 2 हुन्छ ठिक छ। अब यो जुन स्मल एम थियो त्यो त मास पर युनिट लेन्थ हो। सो यसलाई फर्दर हामी के लेख्न पाउँछौँ भने क्यापिटल एम ओभरअल मास पर युनिट लेन्थ एन्ड ओमेगा स्क्वायर एल स्क्वायर बाई 2 हुन्छ। यसलाई हामीले सल्भ गरौँ सल्भ गर्दाखेरि फाइनल रिजल्ट आउँछ 1/2 एम एल ओमेगा स्क्वायर ठिक छ 1/2 एम एल ओमेगा स्क्वायर आउँछ। अब हेरौँ त 1/2 एम एल ओमेगा स्क्वायर हेर्ने हो भने त हाम्रो अप्सन ए मै देखिन्छ देखिँदैन होइन 1/2 एम एल ओमेगा स्क्वायर छ। त्यसलाई हामी क्लियरली भन्न सक्छौँ अप्सन ए हाम्रो करेक्ट अप्सन हो ठिक छ। सो यहाँनिर हाम्रो रिजल्ट आउने भयो एम एल ओमेगा स्क्वायर। सो अप्सन ए इज करेक्ट अप्सन। यसरी हामीले स्लाइटली यहाँ मोमेन्ट अफ इनर्सियामा सल्भ गरेकै कन्सेप्ट अप्लाई गर्दैछौँ। Okay, that was question number 18. Now we are going to solve question number 19. A ball is moving along a circular path if the speed of ball is double and radius half the centripetal force. So, यसलाई यसरी हेरौँ centripetal force depends upon okay पहिला फर्मुला लेख है एमबी स्क्वायर बाई आर हुन्छ। अब यहाँ भएको प्यारामिटरसँग कस्तो डिपेन्डेन्ट हुन्छ भन्ने कुरा मात्र लेखौँ। सर्कल इफ द स्पिड इज डबल स्पिडसँग डाइरेक्टली भ्यारी हुँदैछ रेडियससँग इन्भर्सली। सो यसलाई सिम्पली हामी गर्न सक्छौँ यहाँ डबल भनेको 2v स्क्वायर भयो है यसरी रफली गर्दैछौँ एन्ड रेडियसलाई 1/2 द्याट मिन्स 4 into 2 which is equal to 8. सो इनिसियलको 8 टाइम्स इन्क्रिज हुने रहेछ। यसरी हामी एमसिक्यूलाई सर्टकट वेमा गर्न सक्छौँ। नाउ क्वेसन नम्बर 20. String breaks if the tension exceeds 10 Newton. A stone of mass 250 gram tied to this string of length 10 centimeter is rotated in a horizontal circle. The maximum angular velocity of rotation can be. Okay, so हामीलाई थाहा हुनुपर्छ टेन्सन म्याक्सिमम टेन्सन भनेकै सेन्ट्रिफ्युगल फोर्ससँग इक्वल हुनुपर्छ होइन। कुनै पनि स्ट्रिङमा कुनै चिज एट्याच गरेर हामीले रोटेट गर्दैछौँ भने यतातिर टेन्सन लाग्छ भने यसलाई ब्यालेन्स यो टेन्सनले ब्यालेन्स गरेको हुन्छ सेन्ट्रिपिटल फोर्स अर यसले प्रोभाइड गरेको छ सेन्ट्रिफ्युगल फोर्स। सो यहाँ हामी इजिली क्यालकुलेट गर्नु सक्छौँ एङ्गुलर भेलोसिटी कसरी क्यालकुलेसन हुन्छ भन्दाखेरि हामीले एउटा सिम्पल फर्मुला सक्नुपर्छ है थीटा इक्वल टु एल बाई आर। ओके सो लिनियरलाई रेडियसले डिभाइड गर्ने भने एङ्गुलर आउँछ। त्यसो भए लिनियर निकाल्नु छ भने एङ्गुलरलाई रेडियसले मल्टिप्लाई गर्ने। त्यसै गरी भी लिनियर हो यसलाई एङ्गुलरमा चेन्ज गर्नु छ भने ओमेगा आरले रिप्लेस गर्नुपर्ने देखिन्छ। सो हियर I am going to replace V by omega R and it is square by R. So on cancellation, हामी के पाउँछौँ M omega R पाउँछौँ। ठिक छ M omega R and then भ्यालु सब्स्टिट्युसन गर्ने सिम्पल कुरा किनभने सबै भ्यालु दिएको छ। टेन्सन इज 10 न्युटन मास इज 250 ग्राम एन्ड लेन्थ अफ स्ट्रिङ मिन्स रेडियस होइन। लेन्थ अफ स्ट्रिङ भनेको आखिर यहाँबाट स्ट्रिङ समातेर घुमाइएको छ भने यति लेन्थ हो भने यो रेडियस पनि हो। सो यहाँनिर m r ओमेगा स्क्वायर हुन्छ हामीले ओमेगा स्क्वायर और ओमेगा को भ्यालु चाहिएको सो इजिली हामी लेख्न पाउँछौं यहाँनिर 10 equal to mass is given in gram, that's why we can write here 250 by 1000, and radius is also provided in centimeter, so it can be converted into meter by dividing it by 100 and let it be omega square. Okay, now I'm going to solve 254 times. These 20 cancel out. Okay, and here it will be 10 into 10 multiplied by 4 equal to omega square, and on taking root we can get here 10 and 2 as square root of these two, this overall value. If we take here root, which means angular velocity is 20 radian per second, so its proper answer is option A. Okay, now we are going to discuss question number 21. 500 kg car takes a round turn of radius 50 meter with a velocity of 36 km per hour. The centripetal force is. So this is also quite easy because we are going to use the same relation mv square by r. Here m is 500, and what about the velocity? Velocity is 36 kilometer, that means 1000. If we multiply here 1000, then it will be in meter, and to convert hour we have to divide it by 3600. On cancellation we get the value as 10 meter per second. So velocity is equal to 10 meters per second, and radius is given as 50. So 50 10 times, yeah, and 10 into 100 makes here 1000 Newton. So our answer is correct answer is option C. Okay, so this is question number 21. Now we are going to discuss question number 22. Okay, so let me shift this page. Okay, I'm going to shift this particular page to another page to get another questions. So this is another page, and this one is our question number 22. A body moves along a circular path of radius 500 meter with tangential acceleration this much. When its tangential speed is 30 meter per second, the total acceleration will be. Okay, so as we know that there are two type of acceleration, one is centripetal acceleration and another is tangential acceleration. Okay, and its resultant acceleration is equal to the square root of sum of individual squares of this particular uh, accelerations. Okay, this is the resulting acceleration. Tangential acceleration is provided here. We have to find the centripetal acceleration. So centripetal acceleration equal to v square by r, which means here value of velocity is 30 meter per second, that means 30 square, and radius is 500. Okay, so this is 900 by 500. These two will cancel out, and its value will be 5 1 times, yeah, and 1.8. So its value is 1.8 and its value is 2. Okay, so it will be 2.8 and its square root. So on taking the square root we can get the sorry, one thing I have missed here, we have to take the square as well. So 1.8 square plus 2 square, and on solving these all we can easily get the answer. Okay, so try to solve it and write its answer in our comment box. This is question number 23. Total kinetic energy of sphere rolling with a velocity v is. So as we know that total kinetic energy is the sum of translation kinetic energy and rotational kinetic energy. Okay. So total kinetic energy is the sum of translation as well as rotational kinetic energy. This is quite easy. Okay, so we know that translation kinetic energy can be written as half mv square, and rotational kinetic energy can be written as the this is rotational kinetic energy. It can be written as half mv square, and this can be written as half I omega square, and our options are provided in terms of mass and linear velocity. That's why we have to change these two parameters in uh, velocity linear velocity as well as this moment of inertia in terms of mass and uh, linear velocity. Okay, so the nature of the nature of object is sphere. It is provided here. Okay, so we have to know about the moment of inertia of sphere, and its value is 2 by 5 m r square. So on using this value here, we can easily write it as half mv square plus 1 by 2 multiplied with 2 by 5 m r square, and this is omega square. Okay. Also, we have velocity equal to r omega, which means v square can be written as the product of r square omega square. That's why we can easily replace this product r square omega square by v square. So here and on here we can easily cancel these two also. So it will be half m, this is m, sorry, m v square plus 1 by 5 m v square. Okay, so on solving, let me drop this part. On solving these two, we have to take here LCM as 10. It will be 5 plus 2 and mb square, that means 7 by 10 mb square. So let us take, yeah, option A is our correct option. Now we are going to discuss question number 24. A disk of moment of inertia I1 is rotating freely with an angular speed of omega 1. Then a second non-rotating disk of moment of inertia I2 is dropped on it. The two disks rotate together. The final angular velocity of the system becomes. Okay. So before solving this, we have to understand the question. And in the question, it is given there are two kind of disks. One is already rotating, and we have to drop another disk over it. Okay, before dropping this second disk, the initial disk is rotating with angular velocity omega is 1, and its angular momentum is I1. Sorry, it's angular uh, moment of inertia, not angular momentum. And its moment of inertia is given to be I2. And after uh, dropping this second disk, these two disks rotate together. That means their combined angular velocity, that is supposed to be omega 2. And as there is no external force or external torque acting on this system, that's why we can easily use the concept of conservation of angular momentum. So initial angular momentum and final angular momentum will be equal, and initial angular momentum is the product of moment of inertia of first disk with its angular velocity, and uh, after dropping the second disk over it, the two disks combined with each other. That's why their combined moment angular sorry moment of inertia will be I1 plus I2, and its combined velocity, angular velocity, is omega 2. So we have to find the value of omega 2, which is equal to I1 omega 1 by I1 plus I2. Okay, this is the required solution. So option D is correct option. Well, now we are going to discuss question number 25. The angular velocity of a wheel increases from 10 rps rotation per second to 300 rps in 10 seconds. The number of revolution made during that time is. Okay, so uh, it is provided that initial number of rotation is 100 rps and final number of rotation is 300 rps, and the word is here is mentioned is angular velocity. Okay, so angular velocity is given here. So we are going to use a relation which um, which has number of rotation. That means omega can be written as 2 pi n. This is number of rotation. Okay, so we have to use this particular relation. So on using omega in terms of 2 pi n, and we can also find uh, another expression as omega equal to theta by t. Okay, so to use this expression we have to find first of all theta, that means angular displacement. Okay, to find theta again we have to use one relation omega t plus half alpha t square, and there is one second problem, what is about alpha. So before proceeding we have to find alpha first, and its value is omega minus omega naught by t, and omega can be written as 2 pi n. Okay, so 2 pi we have to take here constant, and final number of rotation minus initial number of rotation by 10. If you take here it will be 40 pi, sum of 40 pi its value. And now I'm going to use alpha here, t here, omega naught here, and omega I'm going to express it as 2 pi n. Okay, so uh, omega can be omega naught can be replaced with 2 pi into 100, and alpha can be replaced by 40 pi, and t can be replaced by 10. Okay, so on using this value here 2 pi, this is initial rotation, that means this is 100, 10. Okay, plus half, this is 40 pi into 10 square. We can easily find the value of theta. And now finally we are going to use the relation, this kind of relation, or there is another relation 2 pi and okay equal to theta by t. So n will be equal to theta by 2 pi into t. This is 10 second, 2 pi, and theta we can get from here. On using these all value we can easily find the value of n. Okay, so uh, try to solve it, and whatever you get, please write on our comment section. Okay, this is our question number 26. A drum of radius r and mass m1 rolls down without slipping along an inclined plane of angle theta. The frictional force. Okay, so as drum is rolling, which means that the frictional force, okay, frictional force in rolling friction, sorry, in rolling friction, as we know that rolling friction, uh, the friction acting between the surface in contact try to roll this object. Without friction, the object cannot uh, get the rotational motion while traveling downward. रोटेशनल मोसन एचिभ गर्नको लागि यहाँ के हुनुपर्छ भने फ्रिक्सनल फोर्स हुनुपर्छ है। फ्रिक्सन फोर्सको युज के को लागि हो भने यो फ्रिक्सनल फोर्स छैन भने स्लिप भएर जान्छ, स्लिप भएन भने फ्रिक्सनल फोर्स छ जसले यसलाई रोटेट गर्छ। त्यसो भए हामीले के बुझ्नुपर्छ भन्दाखेरि फ्रिक्सनल फोर्सले के गर्यो, कन्भर्ट्स द ट्रान्सलेसन इनर्जी अर ट्रान्सलेसन मोसन इन्टु रोटेशनल इनर्जी अर रोटेशनल मोसन। Okay, this is question number 26. Well, भिडियो अलिक लामो भयो, सो आज यो भिडियोमा 26 क्वेसन्सहरू सल्भ गर्दैछु। नेक्स्ट भिडियोमा आफ्टर 27 अप टु मोर देन 70 प्रब्लमहरू, अझै थुप्रै प्रब्लमहरू छन्, ती सल्भ गर्छौँ हामी। र हाम्रो टार्गेट 2000 प्लस एमसीक्यू क्वेसन छँदैछ र एडिसनल अरू टपिकहरूबाट इन्डिभिजुअल च्याप्टर विथ डिस्कसन हैन, अनि त्यसको बेसिक थिङ्सहरू त्यो सबै हामी सेपरेट सेक्सनमा पनि डिस्कस गर्दै जानेछौँ। डिफ्रेन्ट टपिकहरू, कुनै टपिक जान्नु छ भने, कुनै च्याप्टर जान्नु छ भने हामीलाई कमेन्ट बक्समा लेख्दा हुन्छ। कुनै पनि टपिक जान्नु छ, कुनै पनि च्याप्टरको बारेमा बुझ्नु छ भने हामी त्योसँग रिलेटेड पनि भिडियो बनाउन सक्छौँ, बनाउँदै पनि छौँ। हाम्रो एम भनेको सिम्पली सकेसम्म जति पनि इन्ट्रान्स एपियर हुने स्टुडेन्ट छन्, जुनसुकै फिल्डको होस्, माइट बी इन्जिनियरिङ, माइट बी मेडिकल, माइट बी सिएसआइटी, माइट बी बिआइटी है, जुनसुकै फिल्डमा जाँदैछन् भने पनि तिनीहरूको इन्ट्रान्सको लागि फिजिक्स पोर्सनबाट गाह्रो नहोस् भन्नको लागि हामी आफ्नो ट्राई गर्दैछौँ। सो प्लिज सपोर्ट अस एन्ड स्टे ट्युन and share our video, subscribe our channel. Okay, thank you for joining us and thank you for watching.